A hyperbola is the set of all points in a plane such that the absolute value of the difference of the distances to two fixed points is constant. That means if you take any point on the curve, the difference in its distances to two special points is always the same. These two fixed points are called the foci. At the center of the hyperbola, exactly halfway between the two foci, is the center. The vertices are the points on the parabola that are closest to the center. The axis that passes through the center, the vertices, and the foci is called the transverse axis. Perpendicular to the transverse axis is the conjugate axis. The asymptotes are diagonal lines that pass through the center and extend outward. They act as guides that the branches of the hyperbola get closer and closer to, but never actually reach. These lines define the general shape and opening of the hyperbola. A hyperbola can open in two directions, horizontally or vertically, depending on the equation. If the hyperbola opens horizontally, the equation is x squared over a squared minus y squared over b squared equals 1. The vertices are at positive and negative a, 0. The x-coordinates are opposites because the branches open left and right along the x-axis. The asymptotes are the lines y equals plus or minus b over a times x. The foci are at positive and negative c, 0, where c squared equals a squared plus b squared. If the hyperbola opens vertically, the equation is y squared divided by a squared minus x squared divided by b squared equals 1. The vertices are at 0, positive and negative a. The y-coordinates are opposites because the branches open upward and downward along the y-axis. The asymptotes are the lines y equals plus or minus a over b times x. The slope is rise over run. Since the y direction is the rise, the number under the y squared goes on top. That's why the slope is a over b in this case. The foci are at 0, positive and negative c, where c squared equals a squared plus b squared. The foci are located above and below the center and help define how wide the branches open. To summarize, if the x squared term comes first and is positive, the hyperbola opens horizontally. If the y squared term comes first and is positive, it opens vertically. Graph the hyperbola given by the equation y squared over 64 minus x squared over 36 equals 1. The first step is to identify a and b. From the equation, we see that a squared is 64. So a is 8, and b squared is 36, so b is 6. Next, identify the vertices. Because y squared term comes first, the hyperbola opens vertically. That means the vertices are located above and below the origin. So the vertices are 0, 8, and 0, negative 8. Next, find the asymptotes. For vertical hyperbola, the slopes of the asymptotes are plus or minus a over b, which is 8 over 6, or simplified, 4 over 3. So the asymptotes are the lines y equals plus or minus 4 over 3 times x. Next, find the foci. To find the foci, we use the formula c squared equals a squared plus b squared. Plugging in 8 for a and 6 for b, c squared equals 64 plus 36, which is 100. That means c is 10. Since the hyperbola opens vertically, the foci are located along the y-axis at 0, 10, and 0, negative 10. Finally, sketch the graph. Start by plotting the vertices by moving 8 units up and down from the center, which is the origin in this case. To draw the asymptotes, use the slopes of plus or minus 4 over 3. That means from the center, you can go up 4 and right 3 to draw one line, and then down 4 and right 3 to draw the other. These asymptotes form an X shape through the center. Now draw the two branches of the hyperbola. Since it opens vertically, the curves will approach the asymptotes as they move upward and downward from the vertices. Finally, mark the foci at 0, 10, and 0, negative 10, just outside the vertices along the vertical axis. Now that's how you graph the hyperbola y squared over 64 minus x squared over 36 equals 1. Write the equation of a hyperbola with vertices 0, negative 3, and 0, 3, and asymptotes of y equals plus or minus 1/2 x. Since the vertices are directly above and below each other along the y-axis, the hyperbola opens vertically. That means the equation will start with y squared term and follow the form y squared divided by a squared minus x squared divided by b squared equals 1. The distance from the center to each vertex is 3, so a is 3. The asymptotes of a vertical hyperbola have slopes equal to a over b. Since the slope is 1/2 and a is 3, we can set up the equation 1 over 2 equals 3 over b. Solving this gives b equals 6. Now we know both a and b, so let's put this all together. a squared is 9, and b squared is 36. So the equation of the hyperbola is y squared divided by 9 minus x squared divided by 36 equals 1. Write the equation of a hyperbola with foci at negative 3, 0 and 3, 0, and vertices at 2, 0 and negative 2, 0. Since the foci and vertices lie along the x-axis, the hyperbola opens horizontally. That means the equation will follow the form x squared divided by a squared minus y squared divided by b squared equals 1. The distance from the center to each vertex is 2, so a is 2. The distance from the center to each focus is 3, so c is 3. Using the formula c squared equals a squared plus b squared, we plug in the values 3 for c and 2 for a, which gives us 9 equals 4 plus b squared. Solving this, we find that b squared is 5, which means b equals the square root of 5. But we don't actually need to find b, we just need b squared to write the equation. With a being 2, a squared is 4, and b squared is 5. We can now write the equation of the hyperbola. X squared divided by 4 minus y squared divided by 5 equals 1. A hyperbola has an equation 8x squared minus 18y squared plus 16x minus 64 equals 0. Identify the center, vertices, asymptotes, and foci. Our goal is to rewrite this in standard form so we can identify the center, vertices, asymptotes, and foci. To begin, we can group the x terms together and move the constant 64 to the other side. Next, we factor 8 out of the x terms, which gives us 8 times x squared plus 2x minus 18y squared equals 64. To complete the square inside the parentheses, we take half of 2, which is 1, and square it to get 1. We add 1 inside the parentheses, but since we're really adding 8 times 1, we also need to add 8 to the right side to keep the equation balanced. That gives us 8 times x plus 1 squared minus 18y squared equals 72. Now we divide everything by 72 to get the standard form. Simplifying the fractions, we get x plus 1 squared over 9 minus y squared over 4 equals 1. This is a standard form of a hyperbola that opens horizontally because the x term comes first. From the equation, we can tell that the center is at negative 1, 0, since it's written as x plus 1 squared. The value of a squared is 9, so a is 3. This means that the vertices are 3 units to the left and right of the center, located at negative 4, 0 and 2, 0. The value of b squared is 4, so b is 2. The slopes of the asymptotes are plus or minus b over a, which is plus or minus 2 over 3. Because the center is at negative 1, 0, the asymptote equations are y equals plus or minus 2 over 3 times x plus 1. To find the foci, we use the relationship c squared equals a squared plus b squared. Substituting gives c squared equals 9 plus 4, which is 13. So c is the square root of 13. The foci are located left and right of the center, at negative 1 minus square root of 13, 0, and negative 1 plus the square root of 13, 0.